Have you ever wondered how objects move, how a car accelerates or a ball falls? These everyday phenomena are governed by a branch of physics known as kinematics. Kinematics, in essence, is the study of motion. It's not concerned with the forces that cause the motion. Instead, it focuses on the movement itself. Think of it as the what and how of motion, but not the why. To understand this better, let's break down some key terms. Position refers to an object's location in space. Velocity, on the other hand, is the rate at which an object changes its position. It's not just about speed, but also direction. Lastly, acceleration is the rate at which an object changes its velocity. It could be speeding up, slowing down, or changing direction. So, the next time you see a car speed by or a ball drop, remember, it's all about kinematics. Now that we know what kinematics is, let's dive deeper into its fundamentals. Imagine we're embarking on a road trip, starting from City A and heading towards City B. The distance we cover during this trip, the change in our position, is what we call displacement in kinematics. It's not just about how far we've traveled, but also the direction in which we've moved. So, if we're going from City A to City B, the displacement is not just the distance between the two cities, but also the direction of our journey. Now let's think about how fast we're driving. If we're cruising steadily at 60 miles per hour, that's our velocity. Velocity in kinematics is the rate of change of displacement. It's not just about how quickly we're moving, but also the direction in which we're moving. If we're driving at 60 miles per hour towards City B, that's our velocity. If we suddenly turn around and start driving towards City A at the same speed, our velocity changes not just because of the speed, but also because of the change in direction. Finally, consider what happens when we press down or let up on the gas pedal. Our speed changes, right? This change in velocity, this speeding up or slowing down, is what we call acceleration in kinematics. If we step on the gas and our speed increases, we're accelerating. If we hit the brakes and our speed decreases, we're decelerating, which is just a fancy way of saying we're accelerating in the opposite direction. So, to sum it all up, kinematics is the branch of physics that deals with the motion of objects without considering the forces that cause the motion. It's like a road trip, where displacement tells us how far and in which direction we've traveled, velocity tells us how fast and in which direction we're moving, and acceleration tells us how our speed is changing. Thus, in kinematics, we deal with three fundamental quantities: displacement, velocity, and acceleration. Now, let's see how these core concepts play out in real-world scenarios. Imagine this. You're at an amusement park whizzing along on a roller coaster. The heart-stopping climbs and thrilling drops are all thanks to kinematics. Engineers use the principles of kinematics to design these adrenaline-fueled rides, ensuring they're safe and fun. But we're not just talking about theme parks. The same concepts are used in aerospace engineering. When launching rockets into space, precise calculations of velocity, displacement, and time are crucial. Thanks to kinematics, we can accurately predict the path of these rockets, and it doesn't stop at our atmosphere. Astronomers employ kinematics to study the motion of celestial bodies, like planets and galaxies. They're able to predict their positions and movements, helping us understand the universe better. As you can see, kinematics is not just about theoretical concepts. It has practical applications in many areas of life. Let's quickly recap the key points we've discussed today. We started with the mystery of motion, making sense of it through the lens of kinematics. Kinematics is, essentially, the study of motion without considering the forces that cause it. We delved into its key concepts, namely displacement, velocity, and acceleration. Displacement is all about the change in position, velocity deals with how fast an object changes its position, and acceleration is the rate of change of velocity. It's like a chain, each concept feeding into the next. Then, we saw kinematics in action, painting a vibrant picture of its practical applications. From predicting the trajectory of a thrown ball to the motion of celestial bodies, kinematics is everywhere. Remember, the world of motion is vast and fascinating, and kinematics is your key to understanding it. So keep exploring, keep learning, and most importantly, keep moving.